Hey everyone, so this is going to be question number 7. Question number 7 on discussion, and this is generate pre-order. And so what's going to happen here is that we're going to have like a tree, and so in this case, let me draw it out maybe over here so I can draw on it. 6, 7, 8, 9, 10. Yeah, and then so the thing to know about this is that we want to generate like a pre-order traversal of the tree and return that traversal in like a list. And so what does it mean for there to be like a pre-order traversal? So essentially with like a traversal, we're trying to go through all of like the nodes in the tree, like all the values in the tree. And so as you can see here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are all like nodes of a tree. And so what we want to do is our final result should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That list. I guess this one doesn't have, only goes through 7, but let's use this example right here. So how a pre-order traversal would work is that I would first visit the first node at the very top, the root node. My bad. So I would first visit the root node, and then I would then visit the left tree. And then pre-order is kind of like pre-order traversals like kind of defined recursively. So I would first traverse like the very top node, and then I would traverse the left node right after. And so in this case, the traversal of the left node would give me, because I want to first traverse the node and then each of the branches. And so I would traverse the 2, and then I would traverse that branch 3. And so this pre-order traversal down here would give me like 2, 3, for example. And then like I traversed the 1 earlier, and then we're going to move on through the branches. So for this one, I would first take care of like the node 4, and then each of the branches, so 5 and then 6. So my traverse there would be 4, 5, 6. And then in the case with the right one, what happened is that I would first get the label, so 7, and I would traverse each of the branches and add those traversals in. And so in the case of 7, there's only one branch, the 8 branch. And for the 8 branch, I have like 8, the root, then 9, then 10. So our total would be 8, 9, 10. And our total traversal for the tree is just like the nodes that we visited in order. So you started by visiting the 1, then we were visiting like this branch right here, the 2, 3 branch. And for that branch, we visited 2, then 3. And in the case of others, 4, 5, 6, 7, 8, 9, 10. And that's going to be our total pre-order traversal. And so what's going to happen here is that you can imagine what's going to happen. And so how this is going to work is that, let's think about maybe like the recursive call first. And so as I mentioned earlier, like the recursive call, if I were to call like pre-order on like this 2, 3 branch, it would be like this list 2, 3, like all the nodes that we visited in that pre-order traversal, and then 4, 5, 6 right here, and 7, 8, 9, 10 right here. And the question is, how do we get the list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Well, the thing to know about the pre-order traversal is that it's like recursively defined as like first visiting like the root node, in this case the 1, and visiting each of the branches. So this 2 branch, 4, 5, 6, 7, 8, 9, 10. And then what I can do with these like recursive calls, recursive results, is that I can join it in with like the original label. So in the case, the 1 right here. And I can like add in the 2, 3, I can add in the 4, 5, 6, add in the 7, 8, 9, 10, and I should get my total answer. So we're going to go through each of the branches, make a recursive call, and then add those nodes, add those values that we traversed through into like this list that we're maybe keeping track of. And so and let's maybe talk about like maybe a base case. And so general rule of thumb with all base cases is pretty much either 1, we want to stop like traversing through a tree. So for example, if we like came by here, let's say we're looking for the number 7 and we found like the number 7, we'd stop right there. Another condition is when we hit a leaf. And so in this case, a pre-order traversal, there's no reason why we want to like stop in the middle of our tree. There's no reason why we would want to like stop at the 2 rather than going down to the 3, because we're going to have to traverse that 3. So our only base case would be if it's a leaf node. So let's have a really simple example right here. So go 2, going down to 3. And if I call a pre-order traversal of like that list 3, that node 3, well, there aren't any branches, and so the only thing in that traversal of this leaf would be just 3, and so we return the list 3. And so yeah, so let's get coding here. And so let's maybe code up our base case first. And so maybe if it's a leaf, so is leaf of t. And as we mentioned just now, if it's a leaf, there's only one value in that traversal, and it's exactly that label. And so what we're going to return is we're going to return a list containing that label. And yeah, so now we have to handle like the recursive call. And so the idea here is that like we have like a list of like element1, element2, element3, etc. And the idea behind this is that the first element is always going to come from the label t. And so what's going to happen here is that like for example, if I had this tree 1, 2, 3, preorder is defined as first the root node, and then like the left branch and then the right branch traversed afterwards. And so regardless, the first node is going to be maybe like the root node. And so we can start out with like the label of t, and you can imagine that we're going to add the traversals for like each of the branches later on. And then, as I just mentioned, we want to go through each of the branches and add their traversals in. So maybe for b and branches of t. And what do we want to do? We want to add those traversals. So if we call preorder of that branch, we should get some traversal. And so, for example, if this branch was like 2, 3, 4, let's say we're keeping track of like this variable so far total, and currently we have like a list 1, right? And this recursive call right here is going to return 2, 3, 4, and then I essentially want to add these two lists together, so I get like 1, 2, 3, 4. And you imagine that I'm going to like keep, oh, you can't really see it, but down here, right there is the list 1, 2, 3, 4, and we want to keep like accumulating those like traversals. And so preorder is going to return a list of nodes that we traversed, and we want to add it to the existing list. So how we're going to do it is we're going to say total plus equal to preorder of b. And then once we went through all the branches, added in their traversals, we should get the total number, like all of the nodes that we traversed. So at the very end, we can return that total. And yeah. And so also, one other thing to note is that we actually don't need this base case right here. So here we wrote is leaf of t. But remember that if we consider the case when it isn't a leaf, it is a leaf, then total is the label, a list containing the label, but then there are no branches, so it's going to skip through that for loop, and then we're going to return exactly this. So we actually don't need this, and I'm going to cross it out right here. And also, a one-line solution if you're ever curious. Actually, 2-line would be like total equals label of t. Actually, never mind. This is kind of stupid. It's not very useful. Total.extend of preorder of b would be in branches of t. Return total. So this is actually not one line. This is just like one line longer. But yeah, maybe this would work. Okay, sure. Whatever. Whatever. Okay, this was a stupid idea. But anyways, this is the solution for preorder. And then, yeah, let's maybe talk about how we want to turn this into a generator. And so part 2, we want to turn this into a generator rather than like this list that we're just returning. And so the idea behind like converting like a list returning result is like actually pretty similar to that of a generator. And so the idea behind like if you were, for example, like yielding a value, it's essentially saying like if our generator was maybe like a list containing all the values that we were trying to yield in the generator, we're trying to like contain it in a list, then yield would be the same thing as like appending to a list. And then like yield from would be the same thing as like extending to a list, because in the case of like extend, then you would just like add all the values in that list, and like yield from would like add all the values in that other generator or like other iterable. But yeah, so in the case of like the very beginning, we first want to start out by always saying like this first value is going to be the label in our tree, this label of t. And so what we can do here is we can replace this. I'm going to comment it out, like show the equivalent. We're going to replace it with like label of t. So we're giving that first value the label. But then what we want to do is we're going to make a recursive call on each of the branches. So same as before. So for b in branches of t, we're going to call preorder of t. But then what we note about this is that preorder of b is going to return a generator that is going to have all the values that I need. So I'm going to bring this back, diagram. So if I add 1, then 2, 3, 4. If I call preorder of this branch right here, it's going to be the generator that's going to yield me the values 2, 3, and 4. And so how do I yield those values in this recursive call? In the main call. So if I was calling generate preorder on this entire tree, and I made a recursive call, how do I yield those values? Well, I would use yield from. So I would say yield from preorder of b. And what's going to happen is that since preorder of b is going to give me the values 2, 3, and 4, it's essentially saying like yield 2, yield 3, yield 4. So like the next elements of our generator, of our traversal. And at the very end, that means that we've yielded all the values that we needed. So we went through branches, each of the branches, we've yielded those values as well as the current label. At the very end, we should be done. There's nothing else to yield. And then so we're going to, rather than returning the total, we're just going to like stop right there. Yeah, so that's going to be generate preorder. And so, yeah, hope that makes sense and have a great day.